Alright, so this video is on graphing in the coordinate plane. So we're going to learn how to take one of our linear equations and graph it on the coordinate plane here. So remember, since these are linear equations, they should graph as lines. Alright, so the first thing you want to make sure you do is that you have your equation solve for y in terms of x, which means y is isolated. So y is isolated here, so we're good. Okay, so we're going to go ahead and find some points. Making a little table is a great way to keep yourself organized. So we're looking for some solutions of this equation, basically an x and a y that work to make this equation true, okay? And that will be a point on our graph. So you can pick any x's you want. The reason we wanted to solve for y is now we can just plug in for x and see what y's we get. So you don't need to pick hard numbers. I normally pick numbers like 0, 1, and 2. Okay? The only time I wouldn't pick those is if I have some sort of fraction and I need to simplify, but in this case I don't. So I plug in 0 for x, 0 plus negative 6, and I get negative 6. So when my x is 0, y is negative 6. So 0, negative 6 is one solution for this particular equation. Next I'm plugging in 1 for x. So 1 plus negative 6 is negative 5. So when x is 1, y ends up being negative 5. And then I'm plugging in 2 for x. So 2 plus negative 6 is negative 4. So when I plug in 2 for x, y is negative 4. So I have three solutions, and I'm going to graph them. So 0, negative 6. So I start at 0 and I go down 6. 1, negative 5. Go over to 1 and go down 5. And 2, negative 4. Got the 2 and over to negative 4. So before I draw my line, I just want to look to make sure they will make a straight line. If you look at those, they're in a row. So I'm going to make a nice straight line here. It's good to use a straight edge. And you want to go past, you don't want to just connect where the dots are, because this line goes on forever. There's solutions all along here. You can see other solutions that I didn't find, but that are solutions to this equation. For example, right here, right? 3, negative 3. If I had plugged in 3, I would have gotten negative 3. So you see that is a solution. It's just not one I found to make my line, okay? So we just find 3 solutions to make our line. 2 solutions is really all I need, but the third one is to double check that it's making a straight line. And that's all you do to graph, okay? So let's look at another one. So this one, remember your first step is to solve for y in terms of x. So I need to get y by itself. So that means I need to get rid of the x. So if I add negative x to both sides, that equals 0. So y equals negative x plus 3. Sorry, negative 3. Or negative 3 plus negative x. Doesn't matter which order you write it in. Okay? So step 1, solve for y in terms of x. Get y by itself. Now I need my table to find some points. So my x, and then my points will be x, y. So it's just a normal x, there's no fraction, so I'm going to use 0, 1, and 2 again. So when I plug in 0 for x, negative 0 is just 0. There's really no negative 0. So 0 plus negative 3 is negative 3. 0, negative 3. Now I'm plugging in 1. So I have a negative sign in front of the x, so it's negative 1 plus negative 3 equals negative 4. So when I plug in 1, I get negative 4. And then again, I'm plugging in at 2. There's a negative sign. Negative 2 plus negative 3 is negative 5. So I get 2, negative 5. So I've gotten my 3 points. I'm going to plot them on here. So 0, negative 3, 1, negative 4, and 2, negative 5. And look to see if they make a line. If they don't make a line, what you should check. First, what I would check is that you plotted the points correctly. A lot of times when you have a 0, people will make a mistake of coming out here and doing it in the wrong axis. So check your points so that you plotted them correctly, or sometimes you'll ignore a negative and accidentally do 1, positive 4 instead of 1, negative 4. Next, if all your points are plotted correctly, then come back here and check this math. See that you did this math correctly, because maybe you made a mistake with one of these negative signs. It's normally the negatives throw someone off and you make a mistake there, okay? It's really important that when you're solving for y, that you're really careful, because obviously if you get this part wrong, that's going to mess up your whole graph. Alright, so I'm going to go ahead and connect the dots. line. Remember extending, showing that goes on forever. All right, and let's show one more so you really get the idea. So this one's a little trickier of an equation, so I'm solving for y, remember. So I'm going to add negative 8x to both sides. So that becomes 0. So 2y equals negative 8x plus 8. Those are not like terms, I can't combine them. Now I need to get rid of the 2. We'll go 1 over 2. 1 over 2. So I get y equals, and don't forget to distribute that half to each of these terms. So negative 8 over 2 simplifies to negative 4. Don't forget your x. And then positive 8 over 2 simplifies to positive 4. So I get y equals negative 4x plus 4. Right now I have a little room, so I'm going to do my table down here. So I have y equals negative 4x plus 4. So I'm going to do 0, 1, and 2. So I'm going to plug in 0. 0 times negative 4 is 0. Put that out of the way. 0 times negative 4 is 0. Plus 4 is 4. Get 0, comma 4. Plug in 1. 1 times negative 4 is negative 4. Negative 4 plus 4 is 0. And then I plug in 2. Negative 4 times 2 is negative 8. Negative 8 plus positive 4 is negative 4. 2, negative 4. So I had 3 points. I'm going to go ahead and graph them on here. So 0, 4. 1, 0. 2, negative 4. So this is a very steep line. Oops, sorry. Move the other way. Connect my dots. My straight line. Okay? Let's do one more. So if I have alright, let's say that equation. So I add x to both sides, or add negative x, I'm sorry, I add the opposite. So 3y equals negative x plus 3. Do my reciprocal to both sides. So y equals, when I distribute this, negative x times a third is going to be negative a third x. And 3 times a third is going to be 1. Okay? So the reason I wanted to show you one like this is that we have a fraction that our x is multiplying by. So I don't want to pick my usual 0, 1, 2. I still want to pick 0. Okay? Because if I do negative a third times 0 plus 1. So 0 times negative a third is 0 plus 1 is 1. But now watch if I pick 1. Negative a third times 1 plus 1. So negative a third times 1 is negative a third. So then I'm having to do negative a third plus a whole. You end up getting negative 2/3. I mean, you can do it, but that is not fun. And plotting negative 2/3 is not going to be fun. So instead of picking a number like that, okay, I'm going to pick multiples of my denominator, like 3 and 6, because watch what happens when I pick 3 and 6. So negative a third times 3, and I'm going to write 3 as 3 over 1, because you can look to simplify. These would both cancel out the 1s. And so all of this would equal negative 1 plus positive 1, which is 0. So you see how I ended up with a nice whole number, because this canceled out with that denominator. Same thing when I do the 6. Negative a third times 6. I'm writing a 6 over 1. Simplify. This becomes 1. This becomes 2. So I have negative 2 plus positive 1 is negative 1. So think about that when you have a fraction. You don't want to pick your usual 0, 1, 2. You want to look at the denominator and pick multiples of that denominator. Okay? And then we graph that. So 0, 1. 3, 0, 6, negative 1. Okay? Watch out for those 0 points. Those are normally the points that people plot incorrectly. And it would look like that. So that's how you graph linear equations. You notice all of my graphs ended up as lines. Linear equations on the coordinate plane.